Okay, so this is question 1 of the flashback. It says that given that n is a natural number, prove that n cubed plus 2 is not divisible by 8. There's a couple of ways we could do this. So firstly I could say that if n is odd, then I know that n cubed is odd. So if I were to add 2 to that, that will still be odd, and therefore not divisible by 8. That only takes care of odd numbers though, so I'll also need to consider even numbers. So if n is even, I know that n cubed is a multiple of 8. Now I know this because, let's take, for example, 2 cubed is 8, and therefore any other even number to the power of 3 is also a multiple of 8, because I could basically take out 2 cubed from that, and I'll also always have a multiple of 8. So if I was to then add 2 to n cubed, this won't be a multiple of 8, because if we've got a multiple of 8 we add 2 to it. This cannot be a multiple of 8. So finally, for any n then, for any natural number n cubed plus 2 is not divisible by 8. Now another way I could do this is algebraically. So let's say, again, let's start with n being even this time. If n is even, then I could let n be 2k. So n cubed plus 2 would therefore be 2k cubed plus 2, which will be 8k cubed plus 2, and we can see that this bit is divisible by 8. If we add 2 to it, it's not divisible by 8. So, not divisible by 8. What if n was odd then? So if n is odd, then we could say n is 2k plus 1. So this time we'd have 2k plus 1 cubed plus 2. Now if we simplify all of that, we'll get something like this. And this bit is, we can clearly see that's, we could pull 2 out of all of that. That is an even number then. So that's all even. Adding the 3 to it makes it odd. So it now becomes odd, and an odd number is not divisible by 8. So therefore this is not divisible by 8. So we've proven for odd case and even case we're not divisible by 8.